Practice Exam 2016, video 3 of 5 for questions 11 through to 15. Okay, so looking at question 11, we want to find the inverse of y is equal to 2x plus 1 divided by x minus 3. Our first step is we substitute our x for y and our y's for x's. So now we've done that. We've got this y minus 3 term here. So we're going to multiply both sides by this y minus 3. Got y minus 3 multiplied by x is equal to 2y plus 1. So multiplying this through, we've got xy minus 3x is equal to 2y plus 1. So now we want to group our y terms together and our non-y terms together. So we've got xy minus 2y on one side. On our other side, we've got this 1, and we're moving this one over, so this becomes plus 3x. So we have both of these are our y terms. We take y out the front. We end up with x minus 2 is equal to 1 plus 3x. So now we divide both sides by this x minus 2. So here we're left with y is equal to 1 plus 3x divided by x minus 2. Okay, now looking at question 12, we want to sketch here our inverse cosine function. So remembering our inverse cosine function has this shape here. And so generally we're going between minus 1 and 1, and here we're going between pi and 0. So now we've got here this 2x in the middle here. So our 2x, if we think about our domain, this affects our domain. We've got our 2x is between this 1 and minus 1. So if we divide through by 2, we get minus a half is less than, equal to our x is less than our half here. So these values become a half. And if we think about our range here, we see we have this 3 out the front. Normally we're between 0 here and our y in between pi. And we've multiplied that by 3, so this becomes 3 pi. Our 0 multiplied by 3 remains as 0. So here we've got 3 pi. Okay, so now looking at question 13, we've got all of this we want to simplify here. And we might start by working inside the brackets. So we've got minus 2, a to the power of 3, b to the power of minus 1. So what I'll do, I'll start here, I've got 3. So I've got b to the power of minus 1, so I'm going to move that down here, b to the power of 1. And I've got this, so that moves down. I've got this a to the power of minus 1, so that moves up here, a to the power of 1. And my b squared remains here at the bottom in our denominator. So working through here, we've got 2a, 3 plus 1 is 4. Here I've got 3b and 1 plus 2 is 3. And then all of this is squared. This means each term is squared. So minus 2 squared. A to the power of 4 squared. 3 is squared and b cubed squared. So here we get 4. A here it's 4 times 2 is 8. Here I've got 9. 3 times 2 gives us 6. So we end up with 4a to the power of 8 divided by 9b to the power of 6. So for question 4, we want to find the exact solution for this equation here. And we look at this and we think about it. 4 is equal to 2 squared to the power of x plus 2. And then 64 is equal to 2 to the power of 6. So if we multiply this through, 2 to the power of 2x plus 4, remembering to multiply by both terms here, is equal to 2 to the power of 6. So now we have the same base. So our indices must be equal. So 2x plus 4 must be equal to 6. Subtracting 4 from both sides, 2x must be equal to 2. Dividing both by 2, x must be equal to 1. Okay, so moving on to question 15. We're doing the same sort of thing here, but it's going to be a little bit more complicated, isn't it? We don't look at it, 16 is 4 squared, but that's not really going to help us here, is it? So working through from this, we're going to take our logarithms of both sides. So here our natural logarithm of 3 to the power of x minus 2. And our natural logarithm here of 16 to the power of x. So remembering with this, we bring this term out the front. Here and this term here. So here x minus 2 multiplied by our natural logarithm of 3 is equal to x times our natural logarithm of 16. So multiplying this term through, we get x multiplied by natural logarithm of 3 minus 2 times our natural logarithm of 3 is equal to x natural logarithm of 16 there. So what we're wanting to do is group our x terms together and our non-x terms together. So x natural logarithm of 3 minus x natural logarithm of 16 is equal to 2 natural logarithm of 3. Here, so our x is in both these terms. We can take our x out the front here. We get the natural logarithm of 3 minus the natural logarithm of 16 is equal to 2 natural logarithm of 3. We divide both sides by this term here. We're going to get x is equal to 2 natural logarithm of 3 divided by logarithm of 3 minus logarithm of 16 here. And we put this into our calculator and we're going to get minus 1.31 to 2 decimal places there.